super excited to finish up strong, man. I'll let you take over now, and then maybe we will sing a little song at the end of this just to commemorate what a magical conference this has been with all the technical problems and everything.
Great. Sounds good. All right. Thanks, anybody who's listening. My name is Cam Feenstra, and today I'm going to talk about how you can use large language models to punch above your weight. So whether that means, just doing things faster, doing more with less, or even as a small company, potentially competing with bigger companies where you might not have been able to otherwise. So a little bit about my background. When I first came out of college looking to go into the software industry, I was mostly interested in machine learning, and I wanted to go train models, and I had some reasonable skills with sort of Python data analysis, less so training models. But at my first job out of college, I spent a lot of time training machine learning models for doing various NLP tasks. And I actually started to gravitate more towards the software side. I got more interested in kind of the infrastructure. And a big reason for that was just that the feedback loop was so much faster writing software than training models. At least that's how I saw it. Now, that's very much not necessarily the case anymore, which is a big part of what I'm going to talk about today. Sorry. Okay. Let me tell you just briefly about Anzen, which is the company I've been at for about the past year and a half. So the problem Anzen is tackling is pretty big. $23 billion every year is spent on basically employees suing their employers. And that's rising year over year fairly consistently. Today there actually aren't that many good approaches available to businesses. They will buy insurance most of the time, and then separately they'll rely on legal advice for a lot of things. Eventually they might hire a head of HR who knows a lot of domain knowledge about compliance. And so the solution that we've come up with that we think is pretty interesting is in two parts. So number one, we actually sell insurance. We write various different types of lines of coverage to businesses to protect them if they get sued. But we also package a software product that aims to help avoid companies being sued in the first place. Ultimately, time is our most valuable asset. And so even if you're covered when you get sued, it's still not something you want to do. And, sort of a great side effect is oftentimes the things that help companies not be sued are also much better for their employees. And so it can help them offer a better employee experience as well. And for context, we're still quite a small team at Anzen. We're under 20 people, which was sort of the inspiration for the talk. Basically, I'm going to talk about a couple of specific ways that we've been able to deploy large language models to help solve some of our own problems very quickly. And I'll share a few learnings of things we've learned along the way that you might be able to apply to your own work. Probably it's not that big of a surprise that it's hard to compete with a big company as a small company. They have more money, they have bigger teams, they can throw people at a problem. Oftentimes they have lots of valuable data sets that you can't really get otherwise. They have network effects. In the case of insurance, if I know that my friend has had a good experience with a particular company, I might be more likely to just go with them. But on the other side, they're also less agile, slower to deploy to new technologies, whether that be sort of if it's not broke, don't fix it type attitude, or some bureaucracy or whatever it is. And so specifically with the insurance side of our business, we are competing with really big companies. And so the first example I'm going to talk about is how we were able to use a large language model to streamline our underwriting process. So underwriting is basically the process of taking a bunch of information about a company, financials, if they've ever been sued before, a whole bunch of different things. And then a person actually decides, is this a company that's too risky, or do we want to write them an insurance policy? And if we do want to write them an insurance policy, how much should we charge for it? And so what I have here is kind of a diagram of how in the kind of type of insurance we write, how this normally looks. So there's someone called a retail insurance broker that sits typically in between, about 98% of the time, in between the actual client, who is a company who wants insurance, and the insurance company. So generally, the company will approach the broker. They'll have them fill out a long application, which I'll talk about in a second. And then they'll go to any number of different insurance carriers and say, hey, can you give me a quote on this? Those insurance carriers take it back to the broker, who then ultimately takes it to the client. And then if any of them are good, the policy gets issued. And one thing I want to point out here is, maybe you can kind of see from this diagram, each one of these brokers has many clients. And for each one of those clients, they're corresponding with many different companies. And so it's really important for us to make the process for the broker as simple as it can possibly be, or else they're just not going to do business with us. And to give a sort of zoom in a little bit on what traditionally happens inside the insurance company, would be they get this application, emailed or maybe faxed in some cases. They would have actually a team of people who waits for those applications to come in, reads them, determines if they're a duplicate. Sometimes a company might be working with multiple insurance brokers and you only want to process it once. And they'll also manually extract a bunch of different information to make the underwriter's job easier. And then they'll hand it off to the underwriting team, who will decide if they want to write the policy, how much to charge, and send a quote. And just a note about the applications. These applications are really complicated. There's tons of different formats. Generally, insurance companies will accept any format that you give them, as long as it includes the appropriate information. And they're long and dense and have all sorts of questions, which actually makes extracting that information in an automated way quite a challenge. So what we implemented at Anzen is something like this. So you have the broker sends the application. As soon as it hits our inbox, we have an automated classifier that classifies if it's an application. And then we have a separate component that extracts information from it. If the application is a duplicate, it ends there. Otherwise, we send an alert to our underwriting team, who more or less does the same process as in the previous slide. They decide if it's a company they want to insure or we want to insure, and how much to charge. Now, a couple of details about how we put this together. So there's sort of two parts to the solution. There's the classification piece, and there is the extraction piece. And so for the classification piece, we were actually able to put together a classifier that performs pretty well with very little work required on our part. So we started with, we built a classifier based on Google's BERT model, and we I mean, basically the baseline performance was essentially, the same as if we had picked randomly. And we, within kind of an afternoon, we're able to pull down all of the attachments from our team inbox, which was about 300 at the time, manually label them, and then come up with a classifier that had about 95% accuracy, 90% precision, and 100% recall. Now, we did test configurations that had better precision, but there was always a trade-off with recall. And for this use case, we were okay with getting a little bit of noise as long as we captured as much as we could. And we were also tested out a bunch of different models, all open source, on Hugging Face, and a bunch of different training configurations, and we're able to choose the one that had the characteristics we liked the most. For the extraction piece, we actually ended up using an API, AWS Textract, but particularly the question answering feature of AWS Textract, which lets you add a query like, what is the company applying for insurance? And it will extract that from a PDF document, which works very well. They hold their cards a little close to the chest in terms of how it's implemented, but safe to assume based on the performance that there is some kind of large language model powering that under the hood. I just really want to stress, especially with the classification model, this is something that we couldn't pull off the shelf. There weren't any good options. But as I said, we were able to put it together the training data we were able to put together in an afternoon, and basically end to end, we got the whole thing working in under a week. Compared to training a model from scratch, it's sort of at least an order of magnitude less effort and less data than we would have needed to get similar performance otherwise. So now one more example of something that we use large language models for at Anzen. One feature that we wanted to build for our risk management platform, or I guess I should say a hypothesis we had that we wanted to build a feature and validate, is that right now, generally entrepreneurs, startups rely a lot on their lawyers to review individual documents and let them know if there's anything potentially wrong with it. Things like offer letters, separation agreements, if someone gets laid off or something like that. And so we thought it would be a really interesting feature to build a system where someone could just upload a document and get immediate feedback on potential compliance issues. And even though we're not providing legal advice, and that's clearly spelled out on our website and everything like that, for this type of feature, we were really wanted the accuracy to be as high as it could possibly be, because we certainly don't want to tell someone something is wrong or just have completely kind of bogus outputs like you might occasionally get if you use something like ChatGPT. So the first step was that we gathered a bunch of domain knowledge from attorneys. We learned, what are the potential things that you see in offer letters, for example, that are issues. And then we put together a system that looks a little bit like this. So for each type of document, we have a number of different features that we want to extract. For example, for an offer letter, we might want to know what's the salary, is this person an exempt or a non-exempt employee? And then for each one of those features, we sort of have a two-step process. So first, we use sentence embedding to extract the most relevant portions of the document. So more or less something like semantic search. Excuse me. And the second piece is that we use a question answering model to extract the exact bit that we're looking for. So for example, after this step for the salary feature, we would have $40,000, and then we would have exempt or non-exempt. Based on that, we run some business logic and come up with a set of positive and negative insights based on that domain knowledge that we've gathered from attorneys. So in terms of how we actually implemented this, for this, we were able to just pull models off the shelf, specifically a question answering model and a sentence embedding model. The question answering model is, again, based on Google's BERT model. The sentence embedding model is actually not really a large language model. It's based on Microsoft's mini LM, but for this particular task, that was the best performing model that we tried. And additionally, like, it didn't require a ton of data. We had a few dozen examples of each type of document we wanted. And based on that, we were able to sort of manually write prompts to help us extract each feature. Now, I think for this particular feature, at this point, it's too early for us to say if our hypothesis is true or not. We're still developing it and taking it, giving it to people for feedback. The feedback we've gotten so far has been really good, but the main point is that we were able to put this together in about a week, at least for a prototype. And so rather than again, training a model from scratch or something like that, where it would have been a big investment to validate that hypothesis, we were able to do it very quickly. And the end result feels actually fairly kind of magical. So quickly want to go over a couple of learnings. Obviously, this is not a complete list, but so, probably not a surprise, but definitely if you want to host these things on your own, it's important to have someone who knows a lot about infrastructure to do it in a good way. I mean, so, for one thing, these models are really resource intensive. You have to understand how they're going to perform, or if it's all going to fall over under high load. And so, many of the same things that you've always had to do for deploying production systems, you still have to do, and they might even be more important when you're deploying LLMs. And evaluation metrics are also very important. Ideally, you want to be able to quantify if your model is performing as well as it did in tests, or if the performance is going up or down over time. The third point is, if you're running massive production workloads, it does make sense to use the best hardware and everything like that. But especially if you're just working on a prototype or anything like that, it is definitely possible to deploy pretty large models. Maybe when you get to something like many billions of parameters, it wouldn't work so well. But we were able, at least for prototypes, to deploy models on normal CPU instances that we use for other things as well, and they worked well. Now, the last thing I want to call out is something to factor into your costs if you are relying on an API, is that probably you have some layer of business logic on top of the outputs that you get from the models. And so software is all about iteration. And so ultimately, you're going to want to change that business logic. And so, probably you're also going to want to test how different, for example, prompts or different inputs to the model look. If you're relying on an API, doing those changes is very expensive, and in some cases might even be cost prohibitive. So it's definitely something you have to factor into your expectations on cost. Now, maybe anyone watching is thinking, why am I not talking about ChatGPT or something like that? But definitely we do have a lot of cool ideas based on ChatGPT. I've kind of presented the things that we've been able to get into production and are working well. But we think that there's a lot of potential for generative models or something, GPT-4, one of these models, to potentially be a really good underwriting assistant. It might go fetch data about a company. It might just sort of make an initial recommendation. But our experiments have shown that it actually seems to be pretty good at it. And then the second one of the really difficult things about compliance is that the information you need to know is scattered all over the place. That's why, one of the reasons people rely on lawyers a lot of the time. And so, one thing that we think could be interesting would be to be able to ask a question about a specific compliance issue in natural language and get a really great answer based on, or, at least be pointed to the right location. But that's something that is just an idea at this point. So thanks everybody for listening. It's definitely a really amazing time to be alive, really cool time to be in software. I'm super excited about all the advances we've seen in AI. But even without all of the brand new models, large language models can still be a great asset, like they have been to us at Anzen. And last thing is, we are a startup. We're always hiring. So if any of these problems sound interesting to you, or you want to learn more about what we do, please reach out. We're always looking for great people. And thanks to the organizers. Thanks to anyone listening. It's really an honor to speak. And if we have time, I guess I can take a question or two.
For you, there's all kinds of time. There's just a little bit of a delay between the stream and the actual chat that is happening in
I see.
so we can just shoot the shit here for a minute, and then when there is
quality
actual
control,
question,
it's like you want to make sure nothing too bad goes.
Yeah, man. I mean, while we're waiting, there is there's so much good stuff that you're talking about there, but I'm wondering on more of a, again, I want to go more to this philosophical level and talk about, like, if you're working with these large language models and you're dealing with, like, problems that you're not seeing before, what's your main way of going about just debugging shit and being like, wow, I can't Google this because I'm probably the only one in the world that is seeing this right now, right?
Yeah, that's a really good question. Trial and error to some extent. That's always the fallback. I think that to some extent you can. For example, if you have a situation where you have a bunch of possible parameters, like it's actually feels kind of similar to training a model sometimes, because you're like, okay, let me run all of these different things, come up with some metric. Yeah, I guess that's part of the answer, is like, really you just need some evaluation metric. I mean, yeah, like I don't think that there's really, no one on earth can explain what the LLM is thinking, and so like there's no, at least not today, there aren't tools where you can sort of see the flow of information through it and use that to debug what's going on. But traditional kind of software engineering techniques, can also work reasonably well.
Awesome. Did I share this? Hold on, let me share this with you. Speaking of which, I don't know if you've seen this yet.
Yeah.
But
that's pretty cool.
That's the shirt that I made because it's like, yeah, man, we got to call this out. Like, a lot of this, when it comes to reliability and just making sure that there's this big question that I have in my mind, like no amount of prompting, correct prompting, right? Or like no matter how good of a prompt engineer in between quotation marks you are, um, you can't force the model to give you output. So
Yeah.
like how do you go across those kind of problems, right?
Yeah. No, yeah. I mean, it's funny because I probably have seen all of this like AI agent stuff out there, putting one of these on a loop. And that was actually like around the same time it was kind of blowing up. It was an idea I was thinking about, and I experimented, and it's really funny because it's like you give ChatGPT these instructions of like, give me this exact format, do not give me anything else,
Yeah.
blah blah blah, and
And then
it'll
it still spits
always
out.
start with like, yeah, sure, like let me help you. And so, and I memean, ultimately, the models are non-deterministic too, so you don't even actually know, which is a lot different than most software. When you give it an input, you don't even know that the output's going to be the same, especially when you're using something like chat, like an API. They might have completely changed the model
Yeah.
under the hood without
Yeah.
you knowing, and so it's definitely not an easy problem. I mean, I follow all sorts of people on Twitter, and I see there's a lot of people are kind of doing kind of ad hoc, I would say, research on specific techniques, and I find myself frequently kind of bookmarking things of like, oh, that's an interesting idea. Maybe I'll try that sometime. But it's an emerging field, I would say,
Mhm.
and I would guess within the next couple of years it will become, a formal discipline or something of that nature.
Yeah, we'll see. We will see. So there are some awesome questions coming through in the chat that are getting a bit more specific with you. Have you checked with Shape what part of the documents get used most in the classification?
Um, No, I would. I guess the answer is like no. Mainly, we just evaluated the outputs, and we're a small startup. We have a million things to do, and
Mm.
so we kind of monitor how it works as it goes on. But we haven't really dove into like what you're saying. But that's actually a really interesting idea that maybe we should try. Is at least just
Ooh.
evaluate. Does the first 2 pages or whatever like usually yield the same classification result? Um, I just don't know the answer at the moment.
That's awesome. Sebastian, great question. Reach out to me. I got some socks for you. That is what happens when you ask these awesome questions. All right, next up, what are the core parts of underwriting content from LLMs that would need to be evaluated to ensure output? What is required?
Sure. Yeah. So I mean, that's one of the interesting problems. Like, I think I had one slide where I had one of these sort of 9-page applications. And, on top of that, whenever we're underwriting, we get like financials, we get, their employee handbook. And so, ideally, we would just give that all to the LLM and, it would do our job for us. But I mean, maybe with GPT-4, 32K tokens, like it'll be doable, but context size is definitely one of the problems we have to think about when we get deeper into it.
Yeah.
I think that one idea we've been like potentially thinking about is, maybe asking on the first pass, having a large language model or chat GPT or whatever, kind of summarize each document and then put those summaries in kind of the final prompt that makes the evaluation, something like that. But I guess the answer to the question is there's a lot of information that the application, financials, history of if they've been sued, and based on all of those things, we might even ask for more.
Yeah. And like knowing all this, do you feel like the method that you're currently using is the only method that could actually do this? Or are you also looking for like, is there another way?
So doing what specifically?
Like trying to, I guess the idea is the end goal that you're getting at, right? And with feeding all these LLMs, or feeding these LLMs all this data, like I just wonder if there's, and I didn't mean to get so philosophical. I think it's probably because it's late here, but you caught me at a good time. I need my scotch and cigar, and
Yeah,
this
nice.
is it's what you get for being the last one I get to chat with you on this kind of stuff. But
No, yeah,
the
I mean, I love pontificating, so you won't won't find any more
look at
complaints
that
from me.
vocab word, man. Oh my God. Bringing out the real guns. All right. But at the end of the day, it's like the the thing that I wonder about is, do you need to use, because there's a lot of times that we talk about in the MLOps community that machine learning might be over engineering something. And then I feel like now with these new large language models, potentially using them, and in my own experience, when I've played around with them sometimes, I spend so much time trying to get what I want out of it that I'm like, dude, if I just did this, it would have been faster than actually having to do it. So I just wonder, do you ever think about, are you inventing a nail for a hammer, or is this the only way in your mind or in your eyes right now that this can happen?
I mean, I think, yeah, it's a really good question. I mean, I think the traditional wisdom with machine learning has been like use it as little as possible, only when you really need to. And I think that
Hmm.
that's a lot of the reason that for the use cases we put into production thus far, we weren't like, let's just throw a bunch of info at ChatGPT and like let them handle it.
Hmm.
Um, because yeah, I mean, I do think, but also there's things like, I mean, if we tried to create a system to like do underwriting, I mean, there's actually a lot of examples of unsuccessful insurance companies that have tried to do that. And so I think that for unsolved problems, it can work really well.
Hmm.
And but yeah, I mean, I agree. I think that, what will be really interesting is seeing, good software built on top of the large language models. Like, I think a lot of people
Mhm.
say, text is the new UI. Like, I
Yeah.
mean, I love my terminal, but I don't think that's going to happen.
Yeah.
Um, you know and so there's and using large language models presents new UX issues, right? Like
Mm.
oftentimes, I think in the like performance optimization discussion, they got a little bit into like UX fixes for slow models and stuff like
Mm.
that. So um yeah, I think that it is a really cool new primitive, and we'll see kind of what it works for and what it doesn't.
Mhm.
Undoubtedly, there's going to be a lot of things made that are way over engineered and don't actually make any sense. And I mean, I think if you start using large language models where they aren't necessary, it can actually potentially make your software worse because
Yeah.
something you could have just written code for
And it's so
now
slow. Yeah.
only works 80% of the time or something
Yeah.
like that.
Yeah. It only works 80% of the time. It's super slow. I mean, yeah, you're degrading the whole system. So there's another question that came through. How are you getting evaluation metrics?
Um, that's a good question. I would say that at the moment, for our internal classification system, the evaluation metric is that everything goes to a Slack channel, and I take note when I see things that are wrong. And people give me a heads up if it misses something. And then periodically, I've been kind of going back and seeing if I can improve the model. And I always have this original labeled data set that it was trained on. And yeah, I mean, I would say at the moment we're doing things mostly at a small scale, and so the evaluation metrics are still on the manual side. I think that we will certainly over time get to the point where we have things like regression testing and stuff like that in a more automated way. But at the moment, it's just something that we think is important, so we're doing it relatively manually.
Excellent. Dude, Cam, thank you so much, man. You finished us. You finished strong, and this has been incredible. I'm gonna kick you out now, lovingly.
All right.
This is the end of the party. You don't got to go home, but you can't stay here. And so, thank you. We will see you later,
Thanks
man.
so much for having me. Yeah, it was like I said, talks were amazing. Super honored to be able to talk, and yeah.